going to try to do a quick and dirty reverse engineering tutorial. As you can see, this is a throttle body for a CobraJet Mustang. It's a twin 65mm. We're going to design two things for this thing. We're going to actually create a throttle body spacer, a thermal spacer, gasket, and if we have time, we're going to go ahead and try to create a what they call a Bellmouth, which is kind of like a velocity stack. For devices that don't have a mass airflow sensor, you can actually have the flow flowing in through the throttle body, sans a filter, or you can design a filter for it. It's kind of like the maximum airflow that you can have through your engine. Typically, like on this is actually mounted directly to a Whipple supercharger, so you're going to want to try to get the maximum airflow as possible. So we're going to go ahead and quickly design this. So what you're going to want to do is, this is your scan. This is merged with multiple scan sessions and to create a complete mesh model. Everything was complete other than this little area that I hole filled. I did selective hole fill on certain areas. Alright, so what we're going to do, we're going to go ahead and export this model. So we'll export this mesh. We're going to go ahead and send it to your desktop. We're going to create it as an STL. CobraJet. Okay, so first thing you're going to do is you're going to take this and you're going to want to align it. First thing you want to do is align it in an application. You can go straight into your CAD software, but I would highly recommend using something like GOM Inspect. So GOM Inspect is actually a free utility. It's from Zeiss. What I typically use it for is simply just to align your CAD file. So we're going to go ahead and import your file. Okay. And we're going to look for desktop and CobraJet. Open this file. Now, you'll notice that this item is not going to be aligned properly. And this is the reason why you're going to want to do this. And this utility is the best I've seen where you can quickly align. So looking at this, you can see that aligning to this axis, it's just not going to work out. So what I like to do is you're going to go to Operations, Alignment, Initial Alignment, and 3, 2, 1. So you're going to have three options. You're going to have 3 points that you're going to use for your Z, 2 for your Y, and 1 for the X. So I typically try to arrange this by largest to smallest. Okay. So I know this is a large flat area. That's going to probably be my Z. I know this is a known flat area. This is going to be my Y. And then we're going to select this top portion that should be flat as your X. Okay. So let me go ahead and pan over. And remember, our first location we're going to try to do is this. So you're going to do Control. I'm going to go here, here, and here. Okay. Now we're going to do our Y. Control. Boom. And boom. And then our last step, and I'm zoomed in pretty far, so just you can zoom out. We know that I'm going to start with the top of the throttle body. That's the bottom. There's the top. We only need 1 point. So I'm going to hit Control, hit there, and there we go. So now if I hit OK, now I should be able to go to that point. And if you notice, that straight line is almost dead nuts over. Actually, I'm not happy with that. I think this could be better. Yep. We're going to align this sucker. This needs to be inspection, operations. We're going to do this again. Initial alignment 3, 2, 1. I'm going to do this again. I'm going to go Control. Boom. 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 Now we can double check this. Now, if you look, that line is dead nuts. Cross to our X. That line is dead nuts. I crossed. Let's do our Y. Yes, that line is directly across. So, it always doesn't hurt to redo. And see, now that we're looking at this, I don't see it trying to overlap like it was earlier. Okay, so we're going to go ahead and then select it. And we're going to go ahead and export this out. We're going to do STL. I always try to name it as aligned. Okay. Alright, so we're actually done with this program. I'm going to hop over to, we're going to go ahead and close this to save some of our memory. We're going to go ahead and start using CAD now. Alright, so we're in Fusion 360. Quick and dirty. We're going to go ahead and insert mesh. We're going to, from computer, CobraJet align. Let's open this guy. There we go. I know that this should be in the center. I want that in the center. I should be able to flip this. Nope, I want it this way. Center. Okay, hit OK. Alright, we've got this imported into Fusion 360. So the very first step we're going to do is name our spots. So this is our top. You're going to want to move this over here. Name this. Reset current view as top. Going to name it that. Current view as front. Just changing orientation to fit me. It's just the way you bring it in. So that's top. This is your front. Okay. So now we can go ahead and start sketching off of this guy. So first thing we want to do is we're going to go on the back side. And I want this area right here. So we're going to go to mesh. We're going to go to mesh selection. I'm going to select this guy, and then I'm going to select a plane selection. I want to turn my origin on. Sometimes the origin doesn't like to come up, so hide your body. And then we're going to select that guy, so we know we're coming in from there. Okay, we can turn that body back on. We're going to quickly come up to this, and we want this guy to come up to, okay, the bottom. So now that we see, we want to be able to get this surface as clean as possible and get our holes assorted. So that actually looks pretty good. We want to make sure that we get no scan errors. I'm actually pretty satisfied with that. We're going to go ahead and select this, and we're going to hit OK. Alright, so we already have our first sketch, so we can go ahead and go to our sketch. We can go ahead and hit here. We're going to get this, and we're going to edit sketch. We're going to hide this body. Okay, you can see that we got that sketch playing pretty good. And that's actually the body right here. So what we're going to do is use this utility right here. We're going to fit to the curves of the mesh. I am going to focus on the circles. Okay, so we know this is a circle. This is a circle. This is a circle. This one, and this one. Okay, we're going to go ahead here. First thing we want to do is dimension all these. Come on now. I don't know why it's not wanting to let me dimension that. Okay. That's Fusion 360 being Fusion 360. Okay. Okay, so Fusion 360. Okay, so looking at all these holes, we can look at the average. We're seeing 7.5, 7.4, 7.7, 7.6. I'm going to go ahead and say that these are probably 8mm holes. It's just probably the depth that I scanned that I need to correct that. So let's go ahead and do this one. That's 65. Boom. And this one, 65. I think we can safely say that these are 65mm. Almost like the manufacturer wasn't lying about these being 65mm holes. Okay. And then these, I'm going to go ahead and do 8mm. Remember, these are your bolt holes. Ooh. These are going to be 8mm. Now, you could have a change every single one of these holes to the same, like do a equal constraint. I prefer not to do that because at any time I can come back in here and make the change. Okay, so we're going to do one more thing. We're going to sketch follow this. So we're going to exit out that tool. We're going to go ahead and create this. And we're going to fit sketch mesh. We're going to go here. And we're going to see what this guy looks like. I don't want to get too fine a detail because if we do, then we're going to start picking up all the scan artifacts. So what I like to do is 0.1 is fine. Let's do 0.2. Let's go ahead and set this right here, and we can just, we're doing a rough deviation. Okay. And now I can just here spot check and see, yeah, see how that's a nice straight line. That's what we want. Okay. All right. Now let's go ahead and put your body back up here. Now I know that I need to draw a line from here to here. Okay, so what I like to do is create a line that I can see. Now this is just a preference line. This does not need to be exact because all I'm simply doing is just matching against that particular piece right there. So I'm going to go and make sure that's 180 degrees. Go to hit OK. So that line is connecting from here to there. It's doing a separation between these two parts. That's what you want. Okay. Cool. That's what we need. We're going to hit finish sketch. And we're going to go ahead and quickly make our first part. So we can hide bodies. I'm going to go ahead and select this. We're going to do two things. I'm going to go to a solid. I'm going to extrude. I'm going to extrude the first gasket. So the first gasket that I make would be, we would actually be creating a component, and I'm going to be moving away from the body. So we want to make sure we're not going into the body. We want to go away. So that would be 1.5. Okay. Alright, so that's my gasket that I'm making for that body. So, and I'm going to make another part. So you're going to see that we're going to actually create two parts. Alright, I know my throttle spacers that I like to go is, I like to make the parts come to a total of 10 millimeters. So we're going to make a new component. Okay, so that's 1.5. So I am doing a compression setting, so I'm giving it an extra 1 millimeter so I can get your compression going on with the gasket. I'm going to create another component, 1.5. Boom. Okay, well, if you look at that, we just went ahead and created 3 parts. That would be a gasket, 2 gaskets, and a throttle body spacer. And that right there will match your bore, so we can do something called sectional analysis. So, sorry, brain fart. There we go. Now we can rotate around, and you can see we've cropped it in half, and my spacer that we just made with the gasket and everything is not impeding the flow at all. We're going to flow through here, through the throttle plate, through the factory velocity stack. And there you go. You've actually quickly created several parts right there that you can go ahead and send to CNC, or you can actually 3D print, and as long as you make them at a thermal isolating material, you have yourself a throttle spacer. So the next thing we're going to do is we're going to create a velocity stack. So let's go ahead and hide all these components. I'm going to do an analysis, and we're going to do another quick and dirty scan. Okay. So the mouse got away for a second. Okay. We're going to do 2 things. We're going to go ahead and do a sketch surface on here. So we're going to go back to mesh, text plane. We're going to use this body, sectional. I'm going to use this. And then we're going to come over here, and we're going to see about going right at this edge. I want it to come right down to that edge. Okay, I think that's 23. Let's do 22. That's a little too little. We're going to do 22.5. Okay, let's see if we got a clean radius. Not quite. Looks like we got some scan artifacts right there. I want a clean radius. Look at the top. Let's look at the front. What we're concerned with is see how it's gathering that. I need that to be as clean as possible. So let's go ahead and do 23. That's a little bit better. Let's do 24. See, now we're starting to get junk, and I don't want junk. But we can work with that. I think that's going to get us a perfect measurement of what we need to do. I think I'm going to go ahead and do another step further. I want this clean. Okay. Turn off the bodies. Yeah, that looks pretty clean. I don't have any jagged areas. So let's go ahead and hit OK. Okay, so what we're going to do is we're going to go back and edit this sketch. Okay, I'm going to do the same thing, create sketch profile, and I'm going to show you something that you cannot do. Most of this is where 3D scanning comes in play. This looks like an ellipse. It's not a true ellipse. Even with the deviation, it's not going to have a true ellipse. So you going out there with your calipers and measuring this, and measuring from here to here and here to here, you're never going to get this correct, because the manufacturer decided to actually have a ROVAL that's non-standard shape. What they did was they bored these two holes and then basically made sure that the wall thickness and then just radius it across. So this is where having this type of tool set comes really good in handy. Okay. So what I'm going to do is I'm going to try to make sure that when I select this, it's not making a jagged line. I think that looks pretty good for me. And the reason why I do this is I cheat. Okay. So now I go back into here and I'm going to create another line, but this time I am going to use the ellipse. Okay. The reason why I use the ellipse tool this time is a special reason. So I'm not going to rely on this to make anything, but I know that that dot right there is an average of between these two and these two. So that is the true center point that I have now to work with. And the reason why I'm going to work from that is you can take something like this and create that, and we know that that should be the center point. And I'm going to go way off, and I'm going to create that guy. So it'll make sense in a moment, but if you look, that dot is where we imported the scan, the mesh, and this is where it said the center was, but the true center is here. Okay, so you'll see why in a second. Okay, hit OK, finish the sketch. Okay, I'm going to take this guy. No, I don't need him. I just need him. I'm going to go ahead and go to solid. I'm going to extrude. We're going to bring this guy. And this mouse is all over the place today. Because I have bodies turned off, I want to be able to see the bodies, so we're going to create that. Okay. Alright, so this is why I made that. That is our new center point right here. So what I'm going to do is construct offset plane, bam. I'm going to hit OK. Now I can go ahead and hide that body. Hide that body, and I just need that plane. Alright, so you'll see why we're doing that in a second. So now we're going to have another sketch. We're going to go to mesh, go to offset. We're going to select this guy, and then our sectional plane is this. So now we should have a sharp edge right there. We should have a sharp edge up against that. Notice how it's going into the bore. Okay. I don't need to go any further. I know that that's going to be dead center. Okay, so now I can go ahead and hide that. So now I'm going to edit the sketch. Okay, now we're going to do the same thing. We're going to fit mesh curve section. I'm going to do close spline. Okay. I think the tolerances can be, I want to make sure that that's not going to look jagged. No, I like how that's rounding it off. That's going to look good. Let's try to do 2.5. No, that's too much. Let's do 1. Yeah, that's pretty much dead nuts. So let's go ahead and go with that. Okay. Now I'm going to, so first we can turn off that construction line. I know this is my no-go line. That is very important. I need to stay away from this. So I'm going to make basically a construction line across. Okay? This is for my reference that I need to move that over. Okay. Because we can't hit this with the Bellmouth. Okay? So now we're going to go ahead and create a, so we know that this is arched up. I'm going to kind of just use my best judgment. I'm going to come up just a hair, move over, so I want to kind of come into this location. I'm going to space that out. I'm going to, let's go ahead and, I want to be able to come up this and come over about 2, let's go 3 millimeter. Okay, and we're going to do tab. We're going to do 55 millimeters. Okay, and you'll see why we're doing this in a second. This is going to be able to model that into it. Okay, and then I'm going to do another box. I'm basically just going to connect this. And I want to do 3 millimeters. Sure, that looks good. Okay. Okay, and we're going to reference this guy. Ah, well, see, I am completely too low. You want to, we want to basically clip it right there, 0 degrees. Okay, boom. And I know that I need to make, like, model a clamp area into it. So I'm going to come across, well, right here. I'm going to give it the maximum I can probably get by with. I'm going to go, yep, 1 millimeter tab, 14.5. Yep, that looks good. Okay, you'll see what this is for in a second. Alright, so we have that, Now we're going to go ahead and create another box. We're actually going to create a line. Okay, I'm going to move this over about right here. We're going to do 45. Okay. And then now I'm going to do another line. And we're going to go as low as about, okay, so that's 26. We're going to come up to about 22. Okay. Alright. Now we need to go ahead and put some fillets in here. I'm going to select this guy, and we're going to select that guy. And we're going to try to do as extreme of a fillet as we can get by with. That looks pretty good. Yeah, okay. I'm going to create another fillet. We're going to do these two locations. I think that looks pretty good. I want to make sure that we can wrap this around. See, now it's going to break apart, so we can't get involved with too much. 12.5, that looks pretty extreme. That looks good. Okay. Now we're going to duplicate. We're going to do this 3 millimeters. So we know we need to do a 3, and we need to do a -3. Okay. All right. So we're at 31 minutes now. So hit OK. All right. Now we need to close this guy off. Boom. Okay. So that is going to be a pretty extreme looking Bellmouth. So, all right, let's finish sketch. Okay. So now we're going to use something called, not revolve. We can't revolve around a ROVAL, but we can do a sweep. So we're going to select this guy. We're going to select this guy. Sure, we didn't skip anything. So notice that I have that in place. This is where your hose clamp will connect to. If you're going to be printing this or injection molding this into rubber or doing TPU, that would be an extreme. Okay, so now we need to show this guy, and we're going to hide him. Now the location we're going to wrap around is this guy right here. Remember the first line we made? That one right there. I want to do it as a new component. New component. Okay. Boom. Now check that out. You have a throttle body that, ooh, by that little bitty bitty hair, clears the throttle body. You've got a clamp location. We're going to go ahead and put in our spacer, or our gasket, our spacer, another gasket. Look at that. We've modeled thermal gaskets and a velocity stack for a Ford CobraJet throttle body. And the neat thing about this is we can go ahead and put our sectional analysis, and there we go. So let me go ahead and put it on here. As you can see, we've got incredible amount of flow, and we're not restricting or impeding it in any way. And here's the benefit of following that curve, that lip that's on the very top. We can get as close as possible and clamp against the part, and it would actually lock in right there. So there you go. We have two parts that we've just assembled. We're going to do the sectional analysis off, and another thing where we just cleared it. Now, of course, you can clean it up and do, I like to put champers on parts So I would like to chamfer that. I would probably put a 1. It probably won't let me do a 5, but it'll let me do a 2. So you have a nice sharp edge up against that. Boom. You have 2 parts assembled and made. And we just did it in 35 minutes. Okay. Alright, well, I hope you enjoyed the tutorial. Like and subscribe. I'll try to do some more of these videos. Time pending. Alright, have a good night.